Hi everybody, it's Dave here again with another Rocketry project. Today I'm going to be looking at and building the Apogee motor mount adapter kit that allows the use of 38mm high power motors in a 54mm high power rocket. And then we'll also take a look at other types of motor mount adapters that can be used with both high power and model rockets. This is relatively straightforward. We have a thick wall 38mm engine mount tube, and the kit comes with these two rings. So these are centering rings that will fit inside the bigger motor mount. And then we've got one other ring here, and this acts as the stopper for the motor mount. So this would have the same purpose as the retaining ring on a high power motor. And then this kind of scalloped looking ring will go on over it like this, with the motor inserted here, and then this goes over the motor end, and that sandwiches it into place, and then this entire assembly gets put into the 54mm motor mount. The instructions for this are relatively straightforward, although printed upside down in this case. What they do recommend is using wood glue for all of this. Unless you just really need to save a few grams of mass, I would recommend using epoxy for everything on here, just because in high power rocketry in general, epoxy is generally the adhesive of choice. It's also going to be more heat resistant than wood glue is. Now you can still use wood glue. Do not use white Elmer's type glue though, as that's just not going to be strong enough, and especially if you live in a humid area like I do here in Arkansas, then the white glue can become weakened by high humidity. Okay, regardless of which glue you use, it's a good idea to roughen up the regions you'll be gluing on this smooth glassine surface, and that just gives the glue a little bit more surface area to hold on to. You'll also want to make sure and check the rings for anything protruding, like there's a little bit here. You need to sand that off. Same thing with this one. Now in the kit, I'd already taken these out, but these are mounted within a board and have been laser cut, leaving just a little bit of wood, enough to keep them in the original board there. But these pops out really easily. These are the cores that I popped out of those rings as well, and I'm going to save these because these could be used for bulkheads in a smaller rocket. Okay, so I'm going to just say that this is my forward end, and I'll mark it as such so I don't get it backwards. And the first ring here is going to get mounted here on the very end of it and flush with the end. Now, one thing to check, if you have a specific rocket that you are planning to use this for, do make sure that the rocket's motor mount is longer than the adapter is. If it isn't, you'll need to push this forward ring back somewhat. Now in my case, I bought this specifically to go into my Nike Ajax, and this is the motor mount tube for it. And as you can see, the adapter tube is just a little bit smaller, and so this means I don't need to change anything. Okay, but if you had a smaller tube than this, again, you might need to push this back a little bit. My guess is that in most cases, the 54mm motor mount here is going to be more than long enough. All right, and then the other ring is going to go up the aft end here. And I'm going to go ahead and again mark this so I don't get them confused. And this is only going to go up about 1/2 inch, or about 13 millimeters from the base. And then the end ring here that acts as the thrust ring, that is going to be flush with the other. So I've got a little bit of 100 grit sandpaper here, and now I'm just going to really quickly rough up the edges here. I don't want to take off a lot of material because my rings are already not that snug. In fact, I'm going a lot deeper onto this than I really need to. Since this will be for the forward ring, we only need that very front edge to be roughed up. Alright, and then my back edge, this can go a little bit farther, is again the ring is going to come back here 1/2 inch. Okay, and it'll extend beyond that just a little. And then my retaining ring will be right here. So I'm just going to rough up everything from that point to the end. I'm just going to get the sanding gunk off of there. Okay. So my sanding's done. I'm going to go ahead and mix up a little bit of epoxy here. And for this, I'm going to use a 5-minute epoxy so that I don't need to wait a long time for it to set up. So I have my epoxy here, mixing it up. And you don't need to make up a really big amount here. So we're only doing a few rings. And this will just be for the initial adhesion. Once this is set, I will come back and put in some epoxy fillets to make it even stronger. And so that's looking pretty well mixed. Okay, so I'm going to do the forward one first. And do make sure you wear gloves when working with epoxy, as it can cause hypersensitivity and allergic reactions over time. It's also just very sticky. Okay, so I've got a fairly heavy film all the way around here. Just going to try and even everything out. Okay, so now I'm going to take my first ring and place that on there, and I'm just going to where it's flush. And I'm just going to tap this here a little bit. Note that I've got a protector over my work surface here, because I really don't want epoxy on it. Okay, so that's fine there. You can even have it sticking out a little bit. I'm going to actually move mine down just a hair there. Give me about 1/2 centimeter or so, because this way I can put a fillet on both sides of that ring. Okay. The other thing I'm going to do here is just put a little tiny bit of the epoxy right around the edge of the tube here. And this is just where the cardboard got a little bit mussed up while I was sanding it. Alright, and then I'm just going to take a tissue here and just do a quick wipe. All I'm doing is just locking those fibers down so they don't come loose later on. And it's more of an aesthetic more than anything else. Okay, now I'm going to do the same thing to the back. Alright, so first we need to put on the other centering ring. We do have to be fairly quick about this because I don't want the epoxy to set while I'm in the middle of it. Alright, and I'm going a little bit more to the aft than where the ring is going to be, and that way the ring will push the epoxy ahead of it. Okay, and then again, just trying to get a more or less even amount around here. And whoa! Ha! I mean, I've noticed that, but that was the wrong ring. Alright. Put that one on. Okay, so there's that one. And now, the one I tried to mistakenly put on the forward end, that's the retaining ring. Now this one does have to be flush with the end of the tube. And I'm going to be fairly generous with this one because we won't be able to put a fillet on the very aft end because that needs to remain flush. And getting a fillet on the forward side of it is also going to be difficult because of this other ring that's in the way. Okay, so I'm going to go ahead and slide that on, keeping that flush. And like I did with the other one, I'm going to go ahead and just put a little bit of epoxy right around here. I'm going to wipe it off immediately, so I do notice I have a little bit down inside there. We don't want that. Okay, and my epoxy is just starting to thicken up now, so we're getting toward the end of the working time. Okay. Alright. And one more adjustment here. Okay, so I'm just going to make sure all the rings are on straight and where they need to be. One final check here. Okay, so now I'm going to let this cure, and after that has been done, we'll go through and put some fillets on here. Okay, fortunately we've pushed up quite a bit of the epoxy around a lot of these edges, and so the retainer ring actually has a really nice layer of glue there. We won't need to fillet that. And the aft centering ring here will probably need a little bit more on, and the forward one we can definitely put more on. But most of the thrust is actually going to be taken up by this ring here. There may be a variety of cases where you need to fly a rocket on a motor that is physically smaller than what that rocket's motor mount will take. And this is often done if you have a smaller launch field and simply can't launch on a larger engine that would put your rocket at too high of an altitude to recover safely. Or in many cases, you simply want to save a little money because in general, the smaller the rocket engine is in physical size, the less expensive it's going to be. So for example, for roughly the same price, you can get a 3-pack of standard 18mm motors, or you can get a 4-pack of 13mm motors. Now, the impulse is still going to be the same for that letter code. So this is a half A3. You could also have an A3 or an A10 in a mini engine size. And a half A here has the same impulse as a half A in an 18 millimeter engine. Okay, now this is a full A, but just to illustrate the point. So, for example, any rocket that you could fly safely on an A8, you could fly just as safely on a mini engine of the same impulse and thrust. Now, for a full A impulse in the mini engines, you're limited to an A3 or an A10. So, to be safe, I would fly my A8 rocket on an A10 mini engine. And the same would be true of other motors as well. And so the key thing to watch for is to make sure that the engine you're going to be using as a substitute still has enough thrust to safely lift the rocket. All right, so for our mini engines here, we have a couple of choices. Now, Estes has come out with these plastic motor adapters, which I think are really, really clever. But before they had these, they also had these little kits that you could get to basically make a motor mount that fit into another motor mount. And so in many ways, this is akin to the larger motor adapter that I'm currently working on in this video. So this is the same physical size as this, at least in terms of where these rings hit. Now, this is actually more rings than is usually put on one of these, and the reason I did is because I've got a couple of different models where the motor sticks out or stays in to really wide degrees. In one case, the motor sticks out almost about 2.5 centimeters, whereas other rockets, the motor mount is flush with the aft end of the rocket. And then in order to get the mini engine clip to clear the regular engine clip, this had to come out a little bit farther as well. Okay. And that is something to check on any time you use a motor adapter, is make sure that your rocket's still stable before you try flying it. Either do a string test and try and rotate it around your head, or put it into simulation software and make sure that it's still stable that way. Okay, so in this case, I would put a mini engine in like this, just like you would into a rocket, and then fit that into the normal retaining system for the rocket. And so in this case, this is an Estes generic E2X. It uses a clip, and so I just need to pull this out of the way, put that in until the clip reaches that point. Okay. And then you just got to make sure that one clip does not interfere with another and that you don't have anything blocking your launch lug here. So this would be ready to go, and we just put in an igniter into this as we would normally. Now these plastic ones, they're actually just building up the length and diameter of the motor itself, and they depend on both their internal structure and the retaining clip of the rocket. They don't have their own retaining clip like this one does. So in this case, I would fit this in. Now, this looks really cool, like it ought to be a nozzle, but it's not. This is for the ejection charge here. So we actually put the motor in with the nozzle end of the motor up against the hole there, and that's actually held in pretty good right there. And then there's a mating piece that goes over, and this particular one has a couple of little tiny tabs inside that have to meet up. All right, and now if we compare that, it's the same size as the regular 18 millimeter motor, and this will fit in either with something with a clip retention, okay, like this, or it also works well with screw-on retainers, like on this Tigre, or Tigris, that's misspelled. If someone ever wants to tell me how you're actually supposed to pronounce that rocket, I would love to know. Okay, so this would just fit in here, and the screw-on retainer would fit that way. If you have a rocket that simply uses friction fitting, this will also work. Okay, so minimum diameter rockets like the Wizard here or a Viking, they just depend on friction here. That went in fairly easily. And so just like you would with a regular rocket motor, you would apply a little bit of masking tape here. Okay, until you get a good snug fit, which now I do. On some of these, like the Wizard, where the fins are actually not flush and above the actual end here, you can also take a piece of masking tape and wrap the outside so that half the masking tape is over the rocket itself and half is over the motor. That also helps retain it. But you can only do that if you've got room here. Yep, that's definitely on, as I can't get it out now. There we go. Okay, so this will work with any of the standard retaining systems that we find on 18mm rockets. This one will work on most of them as well. The newer ones that have the screw-on retainer might get a little finicky. We can try that here. And part of this just depends on where the internal ribs are in here that hold everything in place. And then you just have to make sure there's enough clearance for that ring to go through there. And this is really kind of snug. All right, but it will go on. Okay, and now I do have to be a little bit careful. You can kind of see right here the very edge of the motor tube is showing, and I want to make sure that I'm not cramping that down so far that it causes damage to this. Okay, so it tried to peel a little bit there. So this you may have to do on a case-by-case basis. You'll definitely need to load the motor into this before you can get that on. Okay, you're not going to be able to put this on and then move the clip out of the way. Now we can move up a little bit. What if we want to be able to fly a rocket that uses 24mm motors on an 18mm motor? Now, same thing here. First of all, you need to make sure that the motor that you're going to put in there provides enough thrust to safely lift the rocket off. And usually the best way to do that is to simulate it in software like RockSim or OpenRocket. And so, just like before, Estes has these really nice plastic adapters. Okay, the one for the 18mm motors simply fits like this. Okay, and it can go on either end. And this is going to be just a little bit longer than the motor itself. And that's because 18 and 24mm motors up through D are the same length. The D is just a greater diameter. Okay, and that's what the little slots in here are for. Okay, so that if you're using a standard retainer clip, these will fit in, so the clip will fit on here. And so, for example, if I take this is, you can't see the whole rocket in the video here. This is a self-designed 24mm rocket, and it's meant to fly on either D's or E's. But this can simply move in here and then clip in. Okay. Now, if you're using this on a screw type retainer, and I don't have a 25mm millimeter rocket with a screw retainer on it handy at the moment, then the little bit of extra length here probably is not going to make a difference. It'll stick out a little bit further, but in most cases there's enough thread room on those types of retainers to hold it in. Okay. Now, similar to this, what do you do when you've got an E-powered rocket and you want to fly it on a D? A couple of things. Most of the Estes rockets that are meant to fly on these two motors here will come with this spacer. And it just goes in ahead of your D motor to make it the same length as the E. And in fact, you never want to fly the D motor without this, because it'll end up flying up inside your motor mount, which will result in decreased thrust, an increased chance of burning up the aft end of your rocket, and also the chance that this goes up through your rocket. So always make sure you've got this in. And that brings us to the next size. Okay, so what if you've got a 29 millimeter that you want to be able to fly a 24 millimeter engine in? Once again, Estes makes their line of adapters here, and so these can be used with either the D-sized or the E-sized length in the same way. So if you want to use the E-sized one, this simply goes together like this. Now this does, even though it looks like it's almost identical on either end, the aft end does have a retainer ring ridge to it here, because most 29 millimeter rockets don't use thrust rings. They use retaining rings instead. Okay, and generally there are some 29 millimeter rockets out there that do use clips. Most have gone to using some sort of retaining ring system, and so this will fit right in there, and then this screws right on. And in fact, I've launched this particular rocket, which is another self-designed one, in this manner. Okay. Beyond this, then we're getting up into the high end of the mid-power and then the actual high-power rocket engines. And so, for example, you might have a 29 millimeter motor, like this one, that you want to be able to fly in a 38 millimeter rocket. Now, 38 millimeter rockets are generally classified as high power, although some of them are light enough that they can be launched with an F or a G. This particular motor casing will house E, F, and G motor reloads. And so to use that, there are a couple of ways. Apogee makes a version of their adapter that looks pretty much just like the one shown at the beginning of this video. It's just that it's narrower. This one's made by R.E.A.R. It's all completely machined aluminum, so this will stand up basically forever. And this just fits in this way. Okay, and then this ring has two different thicknesses on it. So on one direction, the diameter is such that it fits right up against the motor mount, and the other way you flip it over and it butts up. So this actually covers the aft end. And the one you use depends on the rocket that you're using it in. Okay, so for example, this is a Lock Precision High-Tech, and it's got a 38 millimeter motor mount on it. Okay, in this particular case, I put on a threaded adapter. The rocket itself doesn't come with any type of retention system, and so if you just build the rocket and don't add anything to it, you have to use the masking tape method, which I really don't like to use on high power rockets. And so instead, this fits here. And note, it doesn't extend up the whole length of the tube here. And high power 29 millimeter tubes can be out about that long. Okay, so that they can be more than twice this length. But this is enough length here to keep it stable within the bigger motor mount. And so now this just slides in. Okay, and then for this particular motor mount, we want the thicker of the two sides here. And so this makes it flush with the end of the motor. And then this just goes on over it. Now normally you do this in a vertical position. Alright, but I simply don't have enough room here between the camera and the rocket. Okay, so that fits in nicely like this. And this you can keep doing this until you get up to the largest rocket motors. Now, I don't recommend that you try and do two size decreases within the same one. So, for example, although you could technically have this 29 mount in a 38 motor mount, and then put an adapter in here to put a 24 millimeter motor in there. Yes, it will fit, but most likely a 24 millimeter motor is simply not going to have the power to lift a rocket that's meant to run on a 38. Okay, so just as a general rule of thumb and for safety, don't go down more than one diameter size. Okay, and again, do make sure that whatever motor you're putting in here still has enough thrust and enough total impulse to give you a safe flight. And also make sure that it does not significantly change the aerodynamics, especially your center of gravity versus your center of pressure. That you want to keep that 5-to-1 thrust to weight ratio and at least a 1 diameter distance of the center of gravity ahead of your center of pressure. Okay, any of these can change those parameters and could potentially give you an unsafe rocket. So always, always, always make sure and check that ahead of time. The epoxy is set up. I'm going to let it fully cure overnight. But before we go on, I want to check and make sure that everything fits correctly. So this needs to go inside this motor mount. Okay. And then that's going to go in, so it's just below the rim here. And then a motor would go inside of that. Okay, and then this goes on top, and then we put the retaining ring of the original motor mount on. Okay, so let's see if I can bring this up. Alright, so that centers everything nicely inside there, and you can move it around a little bit to get just the right fit. Okay, but that keeps everything in there. It's not shaking around at all. It's nice and snug. Okay. According to the directions, they recommend painting this outer retaining ring a nice bright color just so you can find it easily. And the only thing left to do here really is to put some fillets along this edge and then also along both edges of the forward side, and it's pretty much done. Some people might want to use some somewhat runnier epoxy, like some 30-minute epoxy, and just make a light coating over the whole tube here, and that's just to make this cardboard a bit more resilient. But keep in mind, if you do that, it will add some more weight to the motor adapter there and to the total mass of your rocket. Okay, I hope this video has been informative for you, and have a good launch.